Hey guys, this is John Michael Hands, and welcome to the OCP Global Summit Virtual Edition for the Storage Workgroup track. We've been talking a ton in the Storage Workgroup in OCP about EDSFF, which stands for Enterprise and Data Center SSD Form Factor. And what it is a brand new family of SSD form factors for data center SSDs. So I'm John Michael Hands. I'm a senior strategic planner and product manager at Intel. I've been managing our data center NVMe SSDs and working a ton on our strategy about form factors, EDSFF, and PCI Express SSDs. So when you look at EDSFF as a family, today we have E1.S, E1.L, and E3. So I'm going to walk through in this presentation and spend most of the time on E1.S and E1.L. Because these are what OCP is using today in designs for cloud and hyperscale, and these are what is shipping today. So the EDSFF is a family of form factors that's kind of built in and been designed from the ground up for SSDs. As you guys know, M.2 was widely used in hyperscale designs around open compute, but it had many challenges for stuff like thermals, hot plug support, and power and performance scaling, as well as capacity limited, because M.2 was really developed for mobile platforms and consumer devices like laptops and mobile devices. So E1.S really solves those challenges in a way that's flexible and scalable. So it remains the small size. E1.S is just a little bit bigger than an M.2. It is wider, so it fits 2 media sites, and you have 4 mounting holes for heat sinks. You can see right here, these are the mounting holes for standard heat sinks, and then you have the high-speed EDSFF connector, which we're going to talk about. Now, there are options for different heat sinks, which we'll get into some of the new discussions at OCP. E1.L is all about scalable storage and about high capacity storage. So optimizing capacity per drive and capacity per rack unit to really deliver the best total cost of ownership for large capacity SSDs. And then if you look at E3, this is really the standard 2U form factor for EDSFF. And we're not going to talk a lot about it today. Now you can take an E3 and turn it horizontally and put it into a 1U as well, similar to U.2, but you can see it does kind of retain the typical drive form factor for 2U designs. And there is some interest in OCP using that in the future for stuff like accelerators, maybe future versions of OCP NIC or higher performance devices. So what is EDSFF? EDSFF is a family of form factors and standards for data center SSDs. It's been developed really to improve the capacity, thermals, and power and scalability. So really addressing all the challenges that previous SSD form factors had because they weren't designed natively for SSDs. So just like with NVMe Express and NVMe, we really got a brand new fresh start on an SSD protocol and spec that wasn't designed for hard drives and rotating media. So EDSFF is kind of like the NVMe for form factors, really, when you get to look at a family of requirements and form factors for the data center and say, what do we actually need? Well, you want high capacity SSDs that are scalable and low cost. You want really good thermals and power and different scalability for different platform use cases. So you want these flexible options. And that's part of the reasons why we got some of these different variants of EDSFF, because they are optimized for different things, where the E1.S is really optimized for scalable performance, whereas the E1.L is really about capacity. You have this high-speed multi-use connector with a robust ecosystem. We're going to go through all the different ecosystem and OCP parts that are using this connector, which is called the SFF TA1002 connector. You have full hot plug support across all the different EDSFF form factors. One of the unique things about the EDSFF form factors is the drives themselves have built-in LEDs. They have a carrier-less design. Now you can saw that there is an E1.S that has mounting holes for a carrier, but you have standard options with a integrated enclosure that actually has the LEDs and enclosure and everything built into the SSD. So you buy the SSD off the shelf and it's ready to go into a platform. No need to put it into a third-party carrier or using fancy light pipes with drive sleds or whatnot. And the enclosures themselves have protection from ESD and fully customizable. I think there's a lot of interest in making customizable designs. So the latch pops right off and you can have some really cool OCP-inspired designs, which makes it toolless and hot removable in flight. And then you have a common pinout for SSDs. So even though there are 3 variants of the EDSFF form factors, so E1.L, E1.S, and E3, they all use the same pinout for the SSD. They all use the same connector, and they really are a family of form factors. So I'm going to give a little bit of history about the EDSFF work group. In Q1 of 2017, the EDSFF work group was formed with basically to describe and solve the challenges that I mentioned, which was, hey, there are SSD form factors that weren't really developed for SSDs natively. They were being used for hard drives and kind of adapted to SSDs, or SSD form factors like the M.2, which was developed for mobile devices, but not really data center first. In Q3 of 2017, Intel launched the Ruler SSD at the Flash Memory Summit in 2017, and with full intentions to contribute this to EDSFF. So I happen to have been the product manager for the Intel Ruler SSD, which was awesome. I got to talk to customers about this and really pitch the designing an SSD form factor from the grounds up and really solving all those challenges for hot plug, serviceability, manageability, high capacity, thermal and power scaling. But the number one feedback I got from customers was, this is great, but it needs to be a spec. So we did hand that off into the EDSFF work group, which got contributed into SNIA in Q4 of 2017. So there really is no EDSFF working group per se anymore. The EDSFF specs and standards are maintained as part of the SNIA SFF work group. So in Q1 of 2018, the SFF work group actually published the 1.0 specs for E1.S, E1.L, and E3, which are SFF TA 1006, 1007, 1008, and then 1009 is the pinout spec and signal specification that combines and tells you how to build a PCIe SSD for all those different specs. And you can see there's been various errata and changes to the spec as we have moved from 2018 to 2019. Most notably, the addition of the different variants of the heatsink options for E1.S. So now we have options for the different enclosure sizes, both symmetric and asymmetric. And then one of the most recent things has been the OCP storage work group discussing EDSFF. So that was brought in, and really in Q4, the OCP storage work group kicked off this whole idea of, okay, let's really get together and define the optimal EDSFF strategy so that we can have a really good longevity of the form factor and use it for multiple generations of flash, as well as other devices. And you'll see that one of the outputs of that OCP work group and the storage work group was the addition of the E1.S 15 millimeter, which was added in the 1.4 version of the spec just this year. Really the awesome thing about EDSFF is it uses this high-speed connector. So what you can see here is there's a by 4 variant, this one on the top, a by 8 variant with the 1 notch, and a by 16 variant with 2 notches. And they're all fully interoperable. So you can take a by 4 and plug it into a by 8 or by 16 slot. That's typical like a chem drive today, but it's also backwards compatible the other way with the notch. You can see you can plug a by 8 device into a by 4 slot if it is mechanically and electrically compatible. What you're seeing here is the orthogonal connector, which was really developed to be a low-cost solution for hyperscale and one-use servers, where you can actually route the PCIe lanes directly from the CPU out to this edge connector and do it without expensive cabling or PCIe switches or retimers or link extension devices. So that allows for really low-cost attach of NVMe devices. And then you have, obviously, the different variants of the connector that you can use on a backplane or down on a motherboard as well. So the EDSFF family of drives are all going to use that, and we expect millions of units to be shipped on the EDSFF SSDs. So it'll be a pretty broad use of this ecosystem. But the OCP NIC actually uses the same by 16 connector, this SFF TA1002. So that's really good synergy with the other stuff going on in OCP. Now, there is a SFF TA 1012 that shows the pinout for other types of devices as well, including a native NVMe over Fabrics drive or an Ethernet SSD. They'll be using the same connector. The connector itself is also capable of high-speed cables. So there's been some really cool, unique designs where maybe you could cable out from the CPU over a high-speed cable directly to a slot to where you can have really low-cost attach for PCIe Gen 5 and beyond. And then you can see this PEC-FF, which is really the long-term replacement for a chem card, which has now been donated into SFFTA as 1021, and that has potential options for graphics cards and other higher power devices to also be using this high-speed scalable connector. And really the most important thing is, we see PCIe Gen 5, going to, 32 gigatransfers per second, up from 16 gigatransfers per second in PCIe Gen 4. And then, so that, you really need better signal integrity, on the SSD to basically reduce platform cost on the overhead for PCIe Gen 5. So that's where we see EDSFF getting really exciting. And as we move to PCIe Gen 6 and beyond, when you go away from NRZ to PAM4 and you go to really high speeds, above 50 gigatransfers per second, all the way up to the connectors rated to 112 gigatransfers per second, we have a bunch of longevity in this connector ecosystem. So the first family I'm going to talk about is the E1.S family. So in E1.S, you have a 5.9 millimeter device. You can see here a picture of the Intel drive with this heat shield on it, but it's basically defined in the spec. It could just be a PCB. It could be a drive with a heat shield or heatsink on it, but it basically just has to be within the 5.9 millimeter envelope. And this drive is expected to be a 12 watt device. Now, if you can picture this, but just with a little bit bigger heatsink, is the 8 millimeter device, and I don't have a picture of it, but that extends it out to 16 watts. And then you have the most interesting ones, which are the variants with the enclosures. So you see here, you have a 9.5 millimeter symmetric enclosure, and this looks just like the E1.L, except it's a little slightly less tall as compared to the E1.L, but it fits still vertically into a 1U, meaning the 1U height. It stands just like this as it mates into a 1U chassis. And the current specification calls for up to 20 watts, which is a really interesting point. So for kind of mainstream SSDs in the next few years, 2 and 4 and 8 terabytes NVMe SSDs, this 20 watts is actually a pretty good power range for what PCIe Gen 4 devices will be able to deliver. So this is a really exciting form factor for a lot of reasons, because now you can do things like equivalent U.2 like performance in a much smaller form factor. In this form factor, with a 13 millimeter pitch and a 9.5 millimeter thickness, you can fit 32 to 36 devices across the front of a 1U. So you can have extremely dense I/O platforms with this form factor. And then the new thing that was introduced this year and that got kicked off by OCP is this 15 millimeter design. And I will talk a little bit more about it, but you can see in the spec, it still recommends 20 watts, but obviously with some fins on this, you can expect this to actually dissipate actually much more power if you give it the same CFM. So in the specification, it calls for same power, less airflow, but you can imagine that you could actually use this same device and use it with a higher power envelope, say up to 30 watts. And now you've got a really good case for SSDs for the next 5 years, going to high capacity TLC and QLC. You have storage class memory, like for example, Intel Optane technology, and you really want high performance and higher power to be able to scale the performance per watt. So that's really an awesome option. Now this 15 millimeter device will allow you to do up to 24 devices across the front of a 1U, which is extremely dense I/O performance, compared to what's out there today with U.2. So that's really exciting as well. And then you have the device with the 25 millimeter asymmetric enclosure, which just looks like the 15 millimeter, but with bigger fins. And you can see this allows you to go to higher power or have reduced airflow for a better TCO if you have a similar power drive. And I know I'm not going to go into detail about these because we do have a presentation in this OCP storage workgroup track on thermal's methodology for the EDSFF and how they got there. So this is the most exciting thing, the 15 millimeter. I'm really excited about this because at Intel, we've simulated 25 to 35 watt devices at 35C. You can imagine this could be used for persistent memory and with the CXL interface. It can be used for high capacity QLC drives. It can be used for storage class memory SSDs. It can be used for mainstream TLC SSDs, 4, 8, 16 terabytes in the next 2 to 5 years. Tons of really awesome opportunities. You can see here a prototype that we had produced that was intended for the Open Compute Global Summit that we were going to show off. This is a 3D printed latch that we have. You can see it just mounts here at the two screws. And then you have the EDSFF SFFTA1002 connector here down at the bottom. So this is a really awesome, and we think this is going to have mainstream use at OCP across OCP-inspired platforms. So we really expect, I was looking through some of the, market data on SSD form factors, and it was really surprising that, in the peak of 2018, M.2 accounted for, I think, over 60% of the units shipped on PCIe SSDs into the data center. And that was really driven by OCP customers, that M.2 110 millimeter hyperscale design. So this is really the replacement for that, which is really the next gen high scale, high performance building block for hyperscale flash and storage. So expect this to be kind of everywhere in the next couple of years. I'm going to give a few system design examples for what's out there on the market today. As I mentioned, the 15 millimeter just got released, so there's not really any products out there in the market today, but there are going to be people showing off, new platform designs and some of the new capabilities for the 15 millimeter E1.S form factor. But you can see here, this is an example of an AIC platform that supports 36 E1.S, and these are 5.9 millimeter devices in a carrier, and they have their own latch in a 1U platform. So this is, you can see the CPUs here and the PCIe lanes, kind of routed directly to the back lane, and you can see here, the switches over here. So this is a super high performance system, 36 E1.S drives in a 1U. Same thing. This is like a example from Supermicro just on their website that I grabbed, but they have 32 E1.S across the front of the 1U chassis. So extremely high performance servers. So I'm going to talk a little bit about E1.L. I know I didn't talk too much about the spec because it hasn't changed as much, but I mentioned E1.L was really developed to be high capacity and low cost and best performance, for the best TCO. So one of the things that happens when you build a high capacity U.2 drive, sometimes some of the designs have two PCBs, and those PCBs fold over, and the components on the inside, like the NAND die and the SSD controller, kind of get sandwiched inside of the drive. That's really bad for thermals. So E1.L kind of solves this problem by spreading out the components on a long PCB, and then they're all thermally bonded to the aluminum enclosure. And then you can see they have these latches and LEDs in the front, so it's just easily hot plug, serviceable and removable from the front of a server. And this is an example of a Supermicro system with 9.5 millimeter E1.Ls, and there's 32 of them across the front of the 1U. So with 15.36 terabyte drives today that are shipping in the market, this is about a half a petabyte in 1U. In the next year, we'll have a petabyte in 1U, so extremely dense solutions for that around EDSFF. This is one of the other OCP inspired designs that you can find on the OCP website. It's a server from WeWin that uses the 18 millimeter version of E1.L. So again, for a standard by 4 SSD that's 25 watts, this is probably a little bit overkill, but it's a little bit better for TCO because you can run the fan speed a little bit lower. As you imagine, 18 millimeter heatsink versus 9.5 can just dissipate a little bit more power. But we don't expect this one to be mainstream going forward. I think we are seeing most of the interest in this kind of like 25 watt, E1.L around 9.5 going forward. But the spec does call out both of these, and certainly there are whatever designs are interesting. I think we really look at this as kind of an optimal form factor for a QLC NVMe SSDs. For this form factor supports 40 watts and by 8 PCIe, so there could be accelerator cards or other types of devices that are using this form factor, like FPGAs. So that's really exciting. A ton of different opportunity there, and we're going to hear a lot more about it from the rest of the OCP storage workgroup panel that is, quite frankly, working on actually bringing these solutions to market. So one of the things that will be talked about in this OCP storage workgroup is the cloud NVMe SSD spec from OCP, and I'm not going to get into the nuts and bolts of that because there's a whole presentation on it, but it's really built on EDSFF as kind of the foundation, as the form factor for that going forward. So E1.S, you have U.2-like performance, you have better thermals and more options, different heatsink variants, you have higher performance scalability because you can fit more devices in the front of a 1U. It's been natively designed for the 1U form factor. It's hot plug and serviceable, so you solve the challenges that M.2 had in hyperscale data center. You have flexible heatsink options, so if you wanted to use it like E1.S, like M.2, where there was carrier cards and different adapters, you still have those options, but having a much higher performance device. And it's really optimized for high performance, compute and server optimized scaling performance. E1.L, on the other hand, is really optimized for high capacity JBOD, JBOF. It's still hot pluggable and serviceable, but you really have improved manageability, serviceability, power and thermal capabilities, much better than U.2 as far as using it for high capacity storage. And again, it's 1U optimized. So we really see this as the building block for high performance and high capacity scalable cloud storage. So that's it. The call to action, go obviously attend the rest of the OCP storage work group presentations are really awesome. We have E1.S 15 millimeter. It's actually now already brought into the specification in the 1.4. So we're going to see prototypes and systems out here soon. Join the OCP storage work group. I think there's a ton of interesting stuff going on in the OCP storage work group, specifically around EDSFF. Intel's got a lot of information about EDSFF on our websites. And of course, you can go to the SNIA SFF website to learn more about the EDSFF specification. The EDSFFspec.org isn't really maintained anymore. We're going to probably deprecate it soon now that SNIA actually owns the marketing and the specs for EDSFF. But I just wrote a new page for this SNIA form factors page. It'll be up and live soon. That includes EDSFF. So I'll try to keep that updated so that we have all the latest EDSFF information. And that's it. Thank you guys so much. And I hope you guys learned a lot more about EDSFF in the rest of the OCP Global Summit Virtual Edition. Thank you.
Hello. Okay, excellent. You guys can hear me live. I'm going to answer some of the Q&A. There was a question about from Jason Adrian on when do you see E1.S now having a higher volume compared to U.2. If you guys saw, I did a webcast for PCI SIG on EDSFF pretty recently, and I shared some data from Forward Insights that we think is pretty good that forecasts about 20% of the units out in 2023, I believe, will be EDSFF for PCIe SSDs, and that would account for, if many of those are on QLC on the high-capacity E1.L, that should account for 30 to 35% of the total exabytes shipped into data center SSDs. So, yeah, we actually see quite a bit of traction on E1.S, and I think having OCP, behind it will help, further push that adoption, faster as we look through PCIe Gen 4 and, beyond that to Gen 5. There's a question about any details on CXL in the space. Yes, I think this would be an absolutely great form factor for CXL, and I think that there are some very smart people that are looking at that in doing persistent memory on CXL and the EDSFF form factor. And I think the CXL industry consortium is going to address, kind of recommendations for form factors in the future. But as many of you guys know, CXL runs on top of PCIe 5.0 electricals. So, yes, this would be a fantastic form factor for the CXL interface as well as PCIe and NVMe SSDs. There's a question about, are there any designs using the E3 form factor? So Dell and HP were the original authors of the E3 form factor, and the E3 version 1.0 really never saw any products. Now they are, if you guys follow the SNIA SFF work group, they have actually brought in the EDSFF E3 2.0 proposal into the SNIA SFF work group, and there's just some slight changes that will help actually get higher adoption. Some options to make the E3 short a little bit longer, so an E1.S PCB fits in the E3 enclosure, and the LEDs kind of align. We're actually pretty close to getting that landed, so that will be awesome. So a SSD vendor can take an E1.S PCB and put it in the E3 enclosure and put it in a 2U chassis natively. And then, so they're just kind of finalizing the hardware, and they expect that to be done this quarter. And then we expect to actually see E3 product asks kind of starting with PCIe Gen 4 drives second half of next year and into Gen 5 drives in 2022. It says, question on when is Intel supplying 9.5 millimeter E1.S SSDs? Haha, the 4 terabyte P4511 E1.S that we have in production today is 5.9 millimeters. That was what the spec was when we lost the drive. We are working on getting those other form factors that I just talked about into production as well soon. We have, obviously, it's just a piece of aluminum, but we are having our thermal and mechanical teams do some validation on that. Okay. There is a question on what max spec do you likely see for new 15 millimeter E1.S? 25 watt, 30 watt, 35 watts. Yeah, the spec 20 watts seems low for what we've simulated. I think I don't want to steal the thunder for the thermal presentation this afternoon, but there was some material presented in the OCP storage work group on thermal and power scaling of EDSFF, and that suggested that at mainstream data center temperatures that you could achieve up to 35 watts on an E1.S, which would actually make it higher performance than a U.2 is today. So that would be really awesome, as I mentioned, for Gen 5 devices that could actually utilize that extra bandwidth with extra power. Do you expect PCIe Gen 5 to be used with NAND-based EDSFF? Absolutely. Yes. We are definitely looking at all the options for E1 and E3. What was the reasoning for not standardizing any of the aspects of the latch mechanism and LED locations? This is interesting. Yeah, the LEDs, I believe, are standardized, but the latch, we wanted an opportunity to have some differentiation, and for different designs and that have different requirements. So, but there is an opportunity for OCP here. I kind of mentioned in the presentation that I would love to see an OCP-inspired latch design. Intel has a latch design we have today, and we're going to contribute that, to whatever open source place there is for the hardware. We have no intention of keeping that, proprietary per se. It would benefit the industry to have an industry standard latch that's, high volume and low cost. There's a question from Michael Sloan about how do you see enabling non-standard power consumption airflow combinations? Yeah, that's a tricky question. I think we're going to see as many people noted, there's another question in the other Q&A about, okay, there's a lot of different vendors using different sizes of E1.S, which one's the best, and the 9.5, 15, and 25 all share a common rail, so they can be designed in a platform that are interoperable. If you have a slot that's 25 millimeters, for instance, it should be able to take, mechanically and electrically a 9.5 and 15. But I think we'll have to see what the sweet spot is. I think for cloud storage, we seem to be getting a lot of interest in 15 millimeter. For higher performance designs, 9.5. It seems like because you can fit more devices in a 1U chassis, but that's a whole lot of I/O in the front to enable 32 PCIe by 4 devices. So yeah, I don't know. We'll see some wild stuff here in the next couple of years, but I think the spec is a pretty good place to start. How many E1.S 15 millimeter 25 watts can you fit in a 1U server based off your CFM and thermal study? Yeah, you can fit 24 across with the configuration, the spec defined, you can fit 24 across the front of a 1U, which, compared to a U.2 where you can fit 10 horizontally in the front of a 1U, that is a significantly, higher amount of I/O you can fit in a 1U server and cool adequately. Let me check the Q&A here. It says, can someone post a direct link to SFTA 1006 Rev 1.4? I will do that. It's on SNIA. I will post the link here. I think I answered the question on symmetric enclosure and CFM requirements. There's some questions about CFM requirements and thermals. Yeah, I would, if you guys look at the presentation this afternoon, I forgot what the actual name of it is, but we have a entire session on that. It's called SSD Thermal Simulation Standardization, and that is an entire session where we will go into a deep dive on EDSFF thermal. So, whoops, I'll put that here in the chat. There's a comment about the different options for E1.S on, heat sinks. Don't think of it as different form factors. They are, the same form factor with different thermal variants. All right, it seems like I am out of time, but please you keep attending the rest of the sessions. We have a ton of other EDSFF sessions going on right now, kicking off with optimizing flash form factors for the cloud. So please join that. Thanks a lot. Bye-bye.